Hiding behind that y is a function of x, and that requires the use of the chain rule. That's where the dy dx comes from, and Robin forgot that. Uh-oh, let's get into it. Okay, today I want to talk about implicit differentiation, and I want to give you a good understanding of this before we get started on something called related rates. So, what I have is a circle drawn of radius 5, and I have a tangent line drawn here at the point 4, 3. Okay, you can plug in 4 for x and 3 for y and check to see that that is indeed a point on the circle. What I've also done is I've solved that expression. I've solved this expression for y. Now what I'm doing here is I took the derivative for you and I want to show you the steps. So pause the video and look through these steps and make sure you understand it. The important thing that you get out of this is, one of the things is that the negative 2x pops out as a consequence of the chain rule. Okay, so what I'm going to do now, we end up getting this as the derivative right here. And I want to point out it ends up being negative x. And if you look at this denominator term, right, that is literally just what y is, what I've solved for y. I could write the derivative as negative x over y. Now, let's look at not solving it for y. X squared plus y squared equals 25. Right now, what I'm going to do is I'm going to take the derivative of both sides of the equation with respect to x, like this. Okay. So what I have now is this. I have the derivative with respect to x of x squared plus d dx of y squared equals 0 because the derivative of a constant is 0. Now, this term here is just taking the derivative of a function of x with respect to x, so I get 2x plus. It's this one I want you to focus on, and it's related to the chain rule. The derivative of y squared, or something squared, is 2 times something to the first times the derivative of that something, and in this case that's dy dx. And that's equal to 0. But it's super important that you understand this is just the chain rule consequence, because I don't know what function of y is back there. I mean, I do in this case because I had solved for it already, but generally speaking, I wouldn't. So what I end up now is I'm just going to solve for dy dx as if it were another variable. So I'm going to subtract 2x off both sides, and now I have 2y dy dx is equal to negative 2x, and now I'm going to divide by 2y, and I end up getting dy dx is negative x over y, just like we said it would be. So for this problem, since it's at the point 4, 3, I'm going to have dy dx is equal to negative 4 over 3. Done.